Hello, everyone, and welcome to AWS Heroes in Conversation. Today, we have Renato Losio with us, and he is going to show us how to draw the NYC Skyline with Aurora Serverless version 2. So, Renato, welcome to my channel. And why don't you go ahead and introduce yourself?
Thank you so much. I'm really excited to be here and discuss Aurora Serverless v2 and play a little game to see how the elasticity is going to work out for a serverless database. My name is Renato Losio. I'm Italian, but I live in Germany. I have different hats during the day. Well, as you already mentioned, I'm a data hero for AWS, but on my day-to-day job, I'm a principal cloud architect at Funable, working with private cloud solution for mobile carriers. I'm as well an editor for InfoQ, usually covering cloud-related topics. And yeah, I tend to blog and do little experiment as this one on my own personal blog. That is claudiamo.com. So feel free to follow me if you like.
Renato, just a quick question, even before we move ahead. You said that you like to do all these experiments.
Yes.
What were you thinking when you said that, hey, I want to see if Aurora is elastic enough for you to be able to draw or basically, come up with an NYC skyline? What was the thought process? What was the inspiration behind something like that?
There are two ideas behind that one. Was not my very first experiment with databases in general, because I tend to work with databases. But the idea is I usually find very good presentation that explain you in details how to test something, how to test the elasticity of a service, or how to test the performance of a service, or test some capabilities using performance testing tools that are great to test the environment and see the results, but often don't give a very clear picture to someone who wants to try the service for the first time, or who has no idea how the service works. So the idea was, I want to play around and see how elastic is my database. And I thought, if I can draw something with my database, with the capacity of my database, well, the idea is, we'll see that in details later on, but the idea means I can control the capacity of my database. And if I can control it to the point that I'm able to draw, means that, well, is quite elastic. And then I can compare it to the one that is less elastic and see if there's any difference. That was the idea behind.
Perfect.
So yeah, well, the challenge is, as we say, I just wanted to test Aurora Serverless v2. For the one that don't know what Aurora Serverless v2 is, the second version of the Aurora Serverless. So originally, and still today, is available only for MySQL and Postgres. I'm testing MySQL, but the idea is the same. We're not doing anything that is really too specific to the engine. And the idea is a serverless database. What do we mean by serverless database? I don't want to get involved too much into the discussion, oh, is this serverless? No, this is not serverless. The key point is, as a database where you don't provision the capacity, you don't say upfront, I want, I don't know, 32 gigabytes of RAM, or I want 8 CPU. It's just a database where you want to just have a endpoint. And the cloud provider, so AWS, is going to provide the capacity according to the load you bring to the database. Now, if we want to call it serverless,
do you ever get a question that, is there something truly like a serverless database? Do you ever get that kind of a question, being a data hero? Like, how can a database be serverless?
Very often. I mean, the problem I have with the definition of serverless is that serverless for functions is very clear what it is. It's Lambda. That's great. For databases, unfortunately, became a big topic in the last few years, because databases that are elastic became very popular, because people don't want to provision you don't want to have that your application is elastic, but the database behind is fully provisioned. But as the database, the word serverless is now used for everything. There are scenarios where it's pretty hard to say. I mean, you have different arguments, different position in the community. There are people that argue, and rightly so. I don't want to get too much involved into if it doesn't scale to 0, for example, the capacity is not serverless, or is perfectly fine to have those arguments. My point is, as a data engineer, as a I just want to have something that is elastic. That was my point in this case. Is in most production environment, I'm lucky enough that I don't need to scale to 0, so I can go around that problem. I will say as well, a bit as a joke, that actually, quite funnily, now we talked so much about the word serverless for everything. And if you think about some of the first services that AWS introduced, like S3, SQS, they don't have serverless in their name. Actually, they have simple in their name. Maybe they're not as simple as they want. They added too many features now, but they were not server. But by our current definition of serverless, they are serverless. You don't provision, you pay for what you use. Yes. You don't see anything of the backend. So serverless is not for data. It's not something really new. It's just that it's new for relational databases, for engines that we were using in a provision mode.
But it's a catchy name, so it's a
that's the catchy name. So I prefer to stick to, I want to test the elasticity. I don't want to test serverless. I want to just test the database is elastic enough for my use case. And of course, I wanted to create a simple Skyline. Why a Skyline? Well, because a Skyline, I thought, is a nice thing to draw, and why not? Somehow, well, New York City is easier than other city. We'll see it in a second. And is well known. We'll see anyway a picture just to remember where they're targeting in a second. But I'm Italian, from Milan. I can probably draw the dome, but maybe it's not as popular. I live in Berlin, where, well, the main tower has a big ball that is not really that useful. It's pretty hard to draw with CloudWatch, something like that. So was excluded as well. So, well,
and plus you wanted the ups and downs of the New York City,
yeah,
right?
That was the idea. And to make it harder, as I say, I want to do a simple experiment. The idea was, I don't want to write Java. I don't want to write Python. I don't want to write anything outside SQL. I want something that, as is a game, as is something simple, that I don't want to go for perfection. I just want that something that with just one function written in SQL, people can understand it. So no external tool.
Yeah.
So, now, when you say what triggered me to do it is serverless v2 was introduced as a preview at reInvent 2021 and went GA at the beginning of 2020 and went GA at the beginning of 2022, April 2022. And all the presentation from AWS, they're great presentation, have, of course, those kind of more common use cases. This is one of them where they show you that, well, if you have a web application and you're selling things online for, usually the definition is Black Friday. That's every presentation is Black Friday. Apparently everyone is just doing things at Black Friday. Well, you see that you're in a matter of few seconds, because here the graph is just a few minutes, you see that you have a number of orders, the scales up, peak at a certain time, you have your promotion online, whatever, but the database scales according, and that's cool. That's what you can have. You see that you can process thousands of orders at the same time. That's amazing. But to me, as a single developer that want to play with database, was a bit of a dry image, didn't tell me too much. So I started to play with something else. So my goal was, as I say, this one, because, well, this one is still a bit too complicated for me, but as you can see, it's just a bit of up and down. There's nothing particularly convoluted in this image. So I was like,
this is the NYC Skyline, right? I can see the word.
That's the New York City Skyline. My goal was, let's try to, if I can do something closer to this.
Closer to this, okay.
So how can I do that? Well, first of all, I need to see if the database is really scalable, if I can create some scalability on my database. So first thing, I need some data. Again, I said I want to have something really, really simple. So I thought, can I preload some data? Can I use some testing tool that already loaded millions of records in the database? Well, there are many tools that do that, but I didn't want to start with something so complicated that I have to first load the database. So I thought, can I generate the data I need to generate the load real time? I don't need to have the data there already. So to do even the most simple thing, I needed a table. So I create a table, I call it data, nothing fancy. I just have 3 columns, well, actually, yeah, 3 columns, one ID, because, well, was not really needed, but let's put a primary key, just to present something there. And with auto increment, so I don't have to insert anything there. And then some data time, just and the value. The idea was to pretend that that's some kind of events record. And then the first test that I did was I said I want to stay in SQL. I don't want to go and use a tool outside or a client.
Mm-hmm.
So I just create a procedure. I call it generate some data, nothing else. Just how can I generate some data? Well, I just do a while loop.
Okay.
That's the
I'm
way.
just inserting data in that. Okay.
Yes. And what I'm doing here, I'm just inserting, calling that procedure one time, I'm inserting 5 million records. Why 5 million? Well, I could have put any number. That was just to insert some data and see what happens. That was really my first try to load a database that is serverless. So the idea was, what happens if I create that function and I run it? To make it slightly more complicated, do a bit of, let's call it CPU loaded.
Okay.
Make that. I put some randomic value in the function. So basically, I'm saying instead of inserting always the same data, just add some random value to every line. So the records are all different. Doesn't make a big difference. Was just to make the data that is not always the same record, and then just loop through it. Nothing else. Just one thread, single thread. Nothing more complicated than that. And then I call that my function, call generate data. And here you can see in the last 3 lines that I call it twice. The reason I call it twice, sleeping for 5 minutes between the 2 execution, was a simple test to see if my data, if what I do is reproducible. I mean, if I do 2 runs and the first one is create a weird load and the second one create a completely different load, well, it was already the end of my experiment, because at that point I cannot really control too much. So anyway, that's what I tried. I tried just a very simple basic function that is just those lines. There's nothing hidden. There's no code removed to simplify. No, that's what I
Do you have a sleep for 300 seconds over there,
yes,
right? So that's
is
5
300
minutes.
seconds, 5 minutes. I use 5 minutes because then when I ran it, I realized that it was taking more or less 5 minutes to run.
Correct.
And well, I simply run this code. I basically, if you cut and paste this SQL, there's actually a Git repo that you can reach from my website, and you run it yourself. You run it basically. And what you have on Aurora Serverless v2 is, this is CloudWatch, and you have 2 metrics. What you see is a serverless database capacity that is in orange, and in blue you see the CPU. Of course, the CPU, there's a basic ground CPU that nothing is happening. Between 14:15 and 14:20, there's this leap of 5 minutes. But the first thing we can notice here is we have 2 peaks that are more or less similar. Of course, they are little variation, but I can say up to now that I have 2 little blocks that I can control. I didn't control how high I can go. It goes up to 12 ACU. I'm just controlling how long it's running, more or less, with those 5 million records. And I can just see that if I stop, first thing you notice is the database reacts quite quickly. As soon as I stop, it goes back to a minimum capacity of 4. That is the minimum capacity the database can run. To give an idea, more or less, 4 is about 2 GB of RAM, just roughly.
Correct. So that's where this is the output of the last 3 lines at the previous slide, right?
Correct.
So you have
that's the output of the first
plateau and then another
correct.
peak.
I call the first function, the first procedure. It runs for about 4 minutes.
4 minutes.
Then sleeps 5 minutes, and then it runs for another 4 minutes.
4 minutes.
I didn't control for how much it ran. I just say it runs for 5 million records. It could have been faster. It could have been. I didn't even have expectation. I didn't know what to expect, really. I mean, I'm telling to a database that is not provisioned. I'm telling to a database that is elastic. Just insert those 5 million records. My first, even before running, was it's going to take 20 seconds or 3 hours. I have no idea. I mean, it was just throw it and see what happens, more or less. And I think at some point you reach the peak of the throughput that you can reach with that database, and you just run it. That's what I had. So from my elasticity point of view, was like, oh, I'm quite happy. I mean, I can see that my database scales, and I'm paying, because basically the orange line is what I'm paying for. I mean, it's the capacity that is provisioned, I'm paying for it. You might argue a provision database is cheaper because by CPU is cheaper. If you run it full time, it's cheaper. All those arguments are all valid arguments. In my scenario, I'm basically pay 12 ECU just when I need them. And it goes down pretty quickly. Now, we didn't mention before, we call it Aurora Serverless v2.
V2.
Was there a V1? Yes. Amazon released in the past, a couple of years before, a V1, but is a bit of a different beast. Actually, it's one of the few times that Amazon released two things with the same name, and they call it V1 and V2. They didn't do a new iteration and new features on the same one. They just brought a very new product. V1 had different advantages, like going back to zero as a scaling, but is a single AZ, so that is not really a multi-AZ database, but almost all the scalability algorithm is completely different. It scales down, is not incremental, it doesn't scale by small increment, it always double the capacity. You can think of V1 like doing yourself, write yourself some scripts in Python or in a Lambda function, whatever you want, where according to the CPU metric of the database or the, I'm simplifying a bit, but scale up and down my database. You can do it that more or less yourself. You can say I'm running a 2 extra large instance on Aurora, and well, when the CPU is at 80%, please scale to 4 extra large. So what you can see in this one, you can see if I run the very same function on that database, you can see two important things. First one is that it takes really many minutes before a database scales. It's not immediate, the capacity. It doesn't scale down to zero when I stop for 5 minutes writing. It's actually waiting because it takes much longer to scale down.
Correct.
And as well, actually, you can even say that it scales up to 8 ACU when I've already done all the work that I had to do. So it scales basically too late. For my I mean, my experiment is a bit aggressive. Reality, usually you don't have those spikes that are so immediate, but still, in my scenario, I would have had the capacity provision only when I didn't need it anymore.
So it's not as sensitive as V2.
No,
V2 is pretty sensitive.
V2 is, if we go back, you can see that, the reaction is completely different. You can see as well as the third thing to notice is that before he was able to go up to 12 ACU, so he was going basically to a much bigger database when I need it, while here he reached the point of 8 ACU too late, but when I'm running my test, it's running with a 4 ACU. And that reflects in the time it takes to as well insert those records. It doesn't take any more 4 minutes, it's taking more than double the time to insert those records. So that's really a significant difference in the way that my insert operations are handled by the database. So up to now, I've just shown that, okay, I can create some peaks. Is that enough? Well, not really, because until now, what I did was just insert 5 million records. 5 million records we saw with the difference between V1 and V2 is I cannot really control for how long it rises. So my idea was, oh, well, if I need to draw something, I need to control 2 dimensions, X and Y. X is the duration, I is the height of the CPU. With my previous experiment, I was not really controlling none of them. I was just generating the peak, but the height of the peak and the length of the peak were entirely out of my control because I had no idea. But there's a little change in that function we created before that can do that. Instead of inserting a random number of records, let's say 5 million, you can say, keep inserting record for 1 minute, always. That's one simple way. And at that point, you're saying you don't control anymore how many records you're inserting, but you're just controlling the time. So I can insert my record for 1 minute. Then I can do a slight minor change that can control my height. And this is say, instead of always writing for 1 minute, use a sleep. So if I pass you a value between 1 and 60 seconds, one number between 1 and 59, instead of writing for the full time, just sleep for a certain amount of time. So at that point, let's say that I pass the value 30 is inserting record for 30 seconds, sleeping for 30 seconds. If I give 40, it's basically inserting for 40 and sleeping for 20. So at that point, if you average that, I'm doing it on the minute, you could have done it on the second, you could have done in a block of 10 seconds. I use minutes because it's the simplest metric as well in CloudWatch. The most common one used when I start is the minute. You could change the granularity, but that was the simplest one, so I did that. At that point, instead of just doing a random block, I was saying my new procedure that is called draw block is running always for 1 minute. And during that minute, it might write or it might not write. It write for a certain percentage of the time. So according to the value I call, so I can call draw block 7, call draw block 5, whatever, I'm basically generating hopefully different types. So the very first test was to test that one. So that's what I do. You can see here is I can sleep. I can go up 1 minute. I can sleep playing this. On the first one on the left, what I'm doing is go up 60. The first one is 60 seconds writing, sleep 2 minutes. 50 seconds writing, 2 minutes. The sleep is always fixed there, is 2 minutes. And then 40, 30, 20, 10. And you can see it's kind of little building blocks. It's like the Lego. I can control my little building. I can as well reduce the sleeping time. I can say it's 1 minute between the building block, and then it's exactly the same, but just closer. Or I can remove entirely the sleeping time. I can say 60, 50, 40, 30, 20. 10.
And that's when you have that whole staircase coming down,
Text
right? Like,
on the right one side.
right
Yes.
one, yes. Okay.
At that point, the next step to do the New York City skyline was to take a piece of paper, a ruler, and just measure, really print out that picture and measure how high they were my peaks. So take the highest one and say that one was 60.
Correct.
And then measure, just do a bit of math, quite straightforward math, and just do the next pieces. I'm approximating a bit because, of course, as well, for example, the algorithm scales up much faster than the way it scales down, and that makes a lot of sense because they don't want that. The algorithm makes sense that you don't want to lose, for example, the data you have in your query cache or things like that. But if you average on 1 minute, that disappears. So that's what I achieved here. So I started to draw using that algorithm, I started to draw my New York City.
Skyline.
You might see, I will start to see a bit of a skyline. Not ideal. You can see that the peaks are a bit, every little fragment is 1 minute, that's in half an hour. So the entire project to run with a 1 minute granularity is going to take, sorry, what happened here?
Go back to the presentation.
Yeah, sorry.
Okay.
So, apologies.
No worries, that's fine.
And keep running that. Basically, you can see that, yeah, you achieve something that is not ideal, is not perfect, but is more or less there. It took, yeah, about 1 hour, 45 minutes.
Okay. To put this together.
Yeah, let's put it together because it's between 6:43, I think, and 7:23. So yeah, about 40 minutes. Can you do it faster? Yes, but then the granularity becomes, you need to write the algorithm in a better way that is not, because what I'm doing there is I'm writing, like, for example, for 40 seconds and then sleep 20 seconds. And average on the 1 minute. You will need then to write the function. You can still do it. It's a bit more convoluted. That is then just, it cannot just do 40 seconds and then 20 seconds. It has to do something like every insert should check if you should do it or not. That is a bit more, it's a few more if in the code that it becomes, instead of 20 lines of code, probably a bit more 50 lines, but that's definitely feasible.
But Renato, like right now you have a period of 1 minute.
Right now I have a period of
1 minute. Or your ups and downs,
yes,
or
yes,
right?
They're
if
all
you
1 minute.
decrease that from 1 minute, that is 60 seconds to, let's say, 10 seconds.
I will need to change the algorithm to, you can still do it the very same way, but instead of saying write for 40 seconds, you have to say write for, well, if you say 10 seconds is 40 seconds divided by
Okay, that's fine. I'm not asking for the calculation. I'm trying to ask is V2 that sensitive to kind of
absolutely
to react per second?
Amazon claims, much faster actually. Amazon claims that it can scale in milliseconds. Probably milliseconds is a bit, I'm not saying marketing, but it is well below 1 second. I mean, you can really see the scaling up in a fraction of seconds.
Okay, so it's sensitive enough for that. So even if you
in the scale down, it rightly takes a bit longer than millisecond, but it makes a lot of sense because now we were doing just a game where we are inserting record, but think on a real scenario where you have your data in MySQL, for example, you have your data in your InnoDB buffer pool. The more you shrink the database, the capacity, there's no magic there. There is less memory. The less memory you have means as well that your InnoDB buffer pool has to shrink and be smaller. When it's smaller means that some of your data cannot be anymore in the buffer pool, so not readily available to the user, so faster with lower latency. That means that if you scale down too quickly, you might lose data that the user might still want to use in half a second. So, but it's still a matter of seconds. It's not anymore a matter of minutes, and that's really a key point to me. While V1 was a matter of minutes. It was taking
a few minutes, actually.
Yes, few minutes. And so for really aggressive scenario was not good enough. I think that the main problem that was reducing the availability of V1 was more the fact that it was a single zone and it was taking minutes. There were many things that were making it nice. In some ways, it's quite interesting to see that for some developers, projects, for like internal small projects, V1 was better in some sense because it was scaling to zero, so you could just forget it, leave it there, goes down to zero after a few minutes, and so you don't pay for it. That was great for a developer, whatever. But for a production scenario, for an enterprise that needs the database scaling quite quickly, and V2 is
staying over there as well,
yes,
right? So you pay for that much amount of time as well. Yeah, capacity that you're using. Yes,
absolutely. And that's a bit of I would say a bit of a problem. Yeah. But that's the and
I mean, the problem is solved now with V2, so I think we are good.
The problem is solved with V2. There are still things that we are all hoping as developers that things are going to happen. Like, for example, scaling to zero, I think, is the main feature that is still missing in V2. And as well, the second one that is quite an interesting one is the data API. That's the other thing that made a bigger difference between V1 and V2. V1 had a data API. So you could access, some developers might question, why do you want to have a data API in a relational database? I mean, you can use Dynamo. Yes, it's true, but sometimes you have the data already in your, you have a use case where you're using MySQL or where you have a relational database. You might want to create some KPI, you might want to create a new serverless function, and it's pretty nice to be able to access the data from the data API. Of course, the data API is slower than using, for example, JDBC driver in Java, whatever. There's no pool of connection. It's just opening connection, closing the connection, but had its own case. V2 doesn't have a data API so far. I have no idea. I mean,
maybe V3.
Maybe V3, yes.
I mean, that's the obvious answer over there, right? Maybe V3. Perfect.
That's absolutely the case.
Perfect. Now, this is really good, Renato. I mean, I think this was awesome. I think the fact that you could think about doing something like this, that itself is very fascinating, right? So, thank you so much for coming on my channel today and sharing your knowledge.
Thank you so much.
It was a pleasure having you.
Thanks so much. Talk to you soon.
Take care. Bye-bye.